Hi there, I'm Junaid Ahmed Fazli. I'm recording this video for demonstration of both exercise in our Unix and Linux lab. The exercise is base conversion in shell scripting. So in our normal mathematical numeral system, we are taking base as how many digits or how many characters we use to represent a number. Suppose in the normal decimal system, what we use is 10 digits 0 to 9 to represent a number. In binary we use 2, only 0 and 1. In octal we use 8 digits 0 to 7. In hexadecimal we use 16 digits 0 to 9, and after that A, B, C, D, E and F. So in our exercise we will be converting one base numerical system into another base numerical system. So starting, we have total 5 questions. First one is to convert decimal to binary. For conversion of decimal to binary, we take the decimal number as input from the user. We go on dividing that number by 2 until we get remainder as 1, and remainder at every point, at every division is stored. And it is stored in the order of division. Once we have reached a position where that if we divide the number by 2, we get remainder as 1. At that time, we just reverse the order of the remainders and we get our binary number. So in our program also, I have taken the number as input, decimal number as input, and I just go on dividing that number by 2. Whatever value I'm getting as remainder, I'm storing. First of all, I'm multiplying it by 10, and then I'm just storing it in an order. And once I've reached a point where the remainder is 1, I just reverse the order and print the binary number. Next question is to convert binary to decimal. We are supposed to do the opposite of what we did in the first question. We are given a binary number. We have to multiply the digits by 2 to the power of their positions, and the position starts from right to left from 0. So if suppose we are having 101, which is for binary representation for 5. So what we do is, from the rightmost side, 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2. So that goes for 4 plus 0 plus 1, that is 5. So that's how we get the answer. We get the binary input from the user, and after that we take the positions. After taking the position, we take the 2 to the power of that position, store it into a variable, multiply it with that value and add it to another variable which is assigned as 0 in the beginning. We go on adding the multiplication values to that variable, and at the end we get our decimal number. Next one is from octal to hexadecimal. Okay. Here we will be doing two conversions. First of all, octal to decimal, and then decimal to hexadecimal. The operations are very much alike. Octal to decimal, we will be doing similar thing we did for binary to decimal, just in the position of 2 to the power of position multiplied by the digit. We will be doing 8 to the power of position multiplied by the digit, and sum of all the multiplications, we get our decimal number. Decimal to hexadecimal, we go on dividing it by 16, take the remainder until the remainder comes, I'm sorry, the dividend comes as less than 16. So then we just reverse the order, we get our hexadecimal value. Just the case that if we are getting a value from 10 to 15, we change it from A to F. Next question is, we are supposed to convert hexadecimal to octal. Same thing in opposite. Hexadecimal to binary. First of all, we check for A to F values. convert them from 10 to 15 values respectively. Then we multiply it by 16 to the power of position to that number, add all the multiplications, we get our decimal number. We go on dividing that decimal value by 8, note the remainders, reverse the order of the remainders at the end, we get our octal representation. And the last one is decimal to hexadecimal. The same thing that we have discussed, we go on dividing it by 16. Once we have divided it by 16, we reverse the order, change the value of 10 to 15 to A to F, and we print our answer. So here I am doing the operations. I can give you one example. Mod 8 gives the value of the remainder. So whatever value we have here, we divide it by 8 and get the remainder value in T1. Division by 8 so that we can go on to the next steps. 10 to the power C so that we can use this to append the numbers at the end of the first number, because we will be reversing the order, and then we add all the here we do the multiplication, add the multiplication into a variable, and that's how we get our octal number. So this is the base conversion program that we have done, and we have included all the four bases, the major bases, that is decimal, binary, octal and hexadecimal, and all the operations after performing are working fine. The programs are executed successfully, and the base conversion is done from any value to one base to any other base. Thank you.